All right, time for another draftphysics.com, debatephysics.com also, but not much to debate, so, so we won't bother. Anyway, so there's one comment relevant. Channel 321 guy. Okay, thanks for the answer. So you say momentum in opposite directions must equal at least in ideal conditions. I agree. So that's interesting. But now there's another question. If we first launch a 10 kilogram object with a 1 kilogram object on the other side of a spring, and then the same 10 kilogram object and a 100 kilogram object on the other side, and then the same 10 kilogram with a 100 would the velocities of the 10 kilogram be different in those two cases? In other words, would they have different amounts of momentum? So now I'm just going to change that question because I'm not quite sure what you were saying. 10 kilogram with a 1 kilogram on the other side of a spring, and then the same 10 kilogram object with a 100. Okay, so you're just saying 10 to 100. I don't think it matters on whether it's 10 to 1 or 100 to 10. Same difference. And let's see if this thing works. Good enough, I suppose. All right, so so if the spring is going to be moving, I mean, that is one of the objects isn't stationary. I guess it doesn't matter whether it's stationary or not. If one object's moving into a spring, okay, so you're not starting off with a compressed spring. You're just starting off with a spring, and he's saying you have a 100 kilograms here, and you bring a 10 kilogram in with some kind of velocity, okay. What's going to happen? Well, the argument is the spring is going to start transferring the energy before it fully compresses. So that is, the pressure is going to start to collect in the spring, and it's going to want to just move right through the spring, right? I mean, ideally, if I just pushed on a spring and there was no weight, the spring's not going to compress, right? The spring's just going to sit there and go in the direction that I pushed the spring in. So the spring is going to start to move the object, okay, with a small velocity in this direction, okay, as it compresses. So the weight comes in, the pressure builds, this absorbs the pressure but a little bit slower than the pressure comes in, and so you end up with two events. The first event is you're going to push the 100 kilograms with a small velocity. Then the spring's going to get its full compression, which will only be, say, 80% of what's left of the energy. So 80% is now going to be compressing the spring, and then the 80% is going to go in both directions, okay? So you can sort of argue that 20% will go in this direction during the compression, and then 40% will go in this direction of the momentum. After the compression, and after the re-expansion, and this side will only get the 40. Okay, so you'll have 40% go this way, something like that, and 60% go this way. So you could say it's like the Professor Lewin experiment. So I guess I could illustrate that probably with a better, it's good enough. Better pen, but really don't need one. So the Professor Lewin experiment is basically the one mass cart banging into with a spring, okay? So he doesn't do purely elastic, he does super elastic experiments, so let's understand that. So we have the two mass cart and the one mass cart, and he claims, that the two mass cart goes off with 133%, okay? And I would argue that, no, it goes off with 2/3 of the momentum, and 1/3 of the momentum goes back this way, and that's because he's using a spring. Now, if it was purely kinetic, the argument appears to be, okay, that when they hit, they just split the momentums. So if these were pendulums, okay, hitting each other, a one mass versus a two mass, the argument is that the one mass hits with the velocity, it bounces back with half the momentum, the other, half the velocity. So they have the same velocity, and obviously if it's a 2-to-1 relationship, then this side's going to end up with 2/3 of the momentum, and this side will get 1/3 of the momentum. And the same thing happens with the 1-to-3, apparently. Okay, where half the momentum, no, 2/3, the three-quarters of the momentum goes this way, and 1/4 goes that way, and they both travel 1/4 the velocity. So they travel 1/4 the velocity, 1/4 of the momentum goes this way, 3/4 goes this way, and on and on. Something like that. That would be my prediction anyway. So when you use a super elastic, is different than elastic. And they really should make a distinction between saying inelastic and elastic. They really should make the other condition, which is storage. And the fact is that storage devices release the energy at a different time interval, okay? And so that change in time means that more energy will end up going this way than would go that way, okay, if it wasn't for the spring storing the energy, then releasing it after it's already pushed the object a little bit. So I think that answers the question. Yeah, so I don't know if there's anything else. I will go look and see if there's anything else that I need to respond to, or in some way I'm obligated. Oh, you don't need to see any of that crap. Anyway, so I'll be back. Alright, I'm surprised to see this stupid video. So he left the end of draft science video up where he makes this stupid argument that's physically impossible to be true. He concedes that he's wrong, and now he's still trying to defend it. So he's saying projectile physics, double the velocity gives you 4 times the distance. It's just stupid. It can't do that. All right. And so what he's doing now, I guess, is he's going to shoot it up in gravity, and, change the trajectory. So the smaller object goes higher. I'm just trying to think. The lighter object will do what? That'll be different. Yeah, it'll go higher in the gravity, so therefore it'll go further. But it has, again, this has nothing to do with, the simple premise that twice the velocity, if you're not taking away its velocity, can't be 4 times the distance. So I don't even know why would he do this? I just I look at this silly. It's silly because he doesn't know what velocity he's getting out of that elbow. I mean, that elbow's got to be a horrible change in the velocity. He can't even figure that out. I mean, it's just such a pathetic idiot.
Hello again, chaps. What we're going to do now is some projectile experiments.
Okay, so it's just moronic. He's going to shoot things, so instead of just shooting them straight, okay, he's going to shoot them up. All right, and presumably, I don't know how he can shoot them up even at the same angle, okay, and say, well, he's going to get 4 times the distance, because you will change the arc. So, but I mean, you're not extracting the energy. You're not extracting any energy from the objects, right? You're just pushing them up into gravity and having gravity return them. So you can't extract the energy and call it, you did more work. It's not possible to do more work.
Long tube.
Retard.
The 2 positions where I can drop a steel ball in. That hole there, from the ground, is 1 distance. And dropping the ball in at the top is 4 distance, or 4 heights, more importantly?
So velocity, it's only 1/2 the velocity. So it's twice the velocity from the further point. So he's launching something with twice the velocity up into gravity. It'll take twice as much time for it to reach its apex and then fall. So it'll be in the gravity 4 times as long. Right? Yeah, gotta be.
So because we've got the
Twice as long going up, twice as long coming down.
1 height to 4 heights, that gives us the 2 velocities. 1 velocity, the ball in there, double the velocity of the ball in there. Now the launch, obviously the horizontal launch off the ledge, I was just waiting to see if anybody had picked.
All right, well, whatever. He wasn't just waiting to see. He made an emphatic video that's the truth. He left the video up. It clearly would deceive a moron who watches it, so he's just deceiving people and he doesn't care. So that's really stupid, frankly.
Of course, it only goes twice as far. But now we're going to put roughly a 45-degree launch angle. And now we're going to see what we get.
And it demonstrates nothing because, again, you're not extracting the energy from the object. You're not measuring its energy in any way. So it's just a bullshit experiment. You can't argue that, say, a trebuchet, I could set up a trebuchet to launch something straight up in the air and it comes straight down. Or I can maximize how far it creates a distance. And then the more I try to maximize how far, the more straight I throw it, there's a point where I start losing distance because gravity pushes it into the ground before it runs out of energy, so to speak, before gravity pulls it back down. So there's a diminishing return how high you shoot it, and there's a diminishing return how flat you shoot it. And the ideal is somewhere in between. And the ideal angle is going to be to a velocity. So if you set up the angle to be the maximum distance, the two objects will get the same distance if you change the angle based on the velocity. So again, it's just a clearly unfair experiment. And if you could do it just the inverse, if you just change that angle, you can make the little ball look like, the one at the one velocity, you can make it look like it goes further by just changing the angle.
It's a job to film it, so it won't be quite, I can't get it all in shot. But we do what we can.
Ridiculous.
Of course, there is a mathematical formula for working out the distance of a projectile. And it includes the angle which it launches at.
Yes, duh. So why bother with this experiment? Again, you're not extracting energy or measuring energy. You're just creating a circumstance where obviously the thing with more velocity has more opportunity to travel more distance, but opportunity doesn't mean it had more energy.
Apparently 45 degrees from the surface of the Earth, or the plane in which you're measuring, is the optimum, which is roughly what I've got. And that formula includes a squared velocity term.
Well, it's too bad you don't show anything. So it's too bad you didn't show us the formula you're using, and why there would be any squared velocity term, except to just acknowledge the fact that the twice the velocity means you're going to end up, the arc is going to be carrying it further. But it doesn't have anything to do with measuring its energy, because you're in the gravity 4 times as long. It's going to take longer for it to come back to Earth, so obviously it has more chance to go a further distance, meaning absolutely nothing. It's no different than rolling it and having the same argument about what happens. In terms of, I could argue it's going to be going half its speed 3/4 of the voyage.
So the point here is If it goes 4 times as far...
The point is that clearly he's just trying to contrive experiments to verify what he wants to assert, and they don't. Okay, so if they're well understood, if the experiment's understood, it's understanding that he's not measuring energy here. He's just measuring circumstantial fact that twice the velocity means twice the time to travel before gravity pushes you into the earth. So if you can push an object up higher into gravity, it'll have longer, okay, to travel horizontally.
The distance from twice the velocity, then how is that explained? Because there's no reduction of energy by its velocity of rolling along the surface.
Yeah, it's explained by the amount of time it has to keep going this way, because gravity didn't push it down. It has less opportunity to push it down. Obviously, you go higher in the gravity, you have more time to do this stuff. But that's it. You just have more time. If you launch them and allow them to fall past the plane that you launched them at, okay, then it's going to be back to 2 to 1.
But we'll see what we get. You might not be able to see this string very clearly, but that's 36 inches, and the first string is 9.
Very exciting.
So from one velocity, I think that just landed on the string even.
Fine. And why don't you just see how far they roll too, because that's sort of interesting, isn't it? See how far they go based on the speed you're getting out of your little tube.
Do it again. 3, 2, 1, go.
So a good little bounce. So it hit the ground when it had plenty of energy.
Top of the pipe, which will give us the 2 velocities. It'd be nice with slow-mo, but I haven't got that, unfortunately, but it's past that second string. Just past it. So there's a question for draft science. How now?
So it's not a question. I mean, well, you actually want me to draw it. It's going higher in gravity, right? So the ground is now further away, so now it has more time to go this way, because you're not launching in them, theoretically they're at the same angle, but the fact is, because one of them has twice the velocity, it's going to go twice as high or 4 times as high in gravity. So it's going to take it gets to go 4 times the distance higher. So just like the pendulum, it's going to swing 4 times the distance higher into the gravity. Obviously, that's going to give it a lot more falling time, twice the time actually. And so it has twice the time going up and twice the time coming back down again. So obviously it has more time to go that way, to be consistent with your image. So it's not a challenge. You have to extract the energy. You really don't understand. You're going to tell me how much energy something has. You have to actually extract the energy.
You explain the 4 times the distance. Thanks for watching.
So another garbage experiment. Let's change the rules. Let's bend them and twist them, and we could just put up.
Pascal celebrates Mom Friday and Saturday.
Boy, that is so annoying. I was just going to click on a video and son of a bitches they are. All right, let's just do this.
Suppose you and your...
All right, so let's see if we can find the icon image, because that was a good icon image. Showing these different trajectories there. So the whole point is all you're going to do with twice the velocity is get it higher in the gravity, so now it has a longer amount of time before it hits this surface. But if you got rid of the surface and just let them continue to do on their arc, the fact is you're going to end up with 2 to 1 still. So if you let them continue to fall to even out the experiment, then you're going to see that, oh yeah, well, they did go 2 to 1. You can't change that. So here's another image. So just So this one says 45. That's this angle. Yeah, so that's the green one. So that goes the furthest. And everything else is just doing this. So what are you proving? So you're launching it at this angle. Twice the velocity will get you 4 times the height in the gravity, because that's the rules, and twice the time. And so it's going to be going that way twice as long. Let's see, how else to explain that? Twice as long both ways, going up into the gravity, coming back down, 4 times altogether. Yeah, I don't think there's much else. So you should time how long it takes the object to hit the ground, and then you'll find that yes, this one took 4 times as much time. Twice the time up, twice the time down. All right. Anyway, so that's enough, I think. It's whatever. If this is the best they could do after 300 years, it's pretty pitiful, frankly. They're going to argue this nonsense proves that it's 4 times the energy, when it's clearly they're not collecting the energy. So there's no point in saying it's 4 times the energy, because they're not collecting it. They're just creating again, I could do the opposite. By changing the angle, I can make the results come out differently. So what's the point? There isn't one. Yeah, the point is just to change the subject and try to distract and create noise, to deceive people, as his previous video did. All right, enough of that shit. And such. So anyway, disappointing. So until the next time, and such and so forth and whatnot. Bleh.